So in our last little mini lecture, we introduced the idea of radio telescopes. So let's talk about radio observatories. The idea of radio telescopes started with Grote Reber really building a dedicated radio telescope. Jansky, though he's started the whole field of radio astronomy, really did it kind of on the side in terms of discovering radio astronomy while working on communications. Reber really built the first radio telescope. But the problem there was that this was right before World War II. When World War II started, then a lot of scientists ended up being called up for military duty. Even if they were not actually serving in the military, though many of them were, they were called up to build weapons and counterweapons, radar and things of that sort. So after the end of the war, you had a lot of very technically trained people, and a number of electrical engineers that were interested in astronomy got together, and they helped to build the first radio observatories, large radio telescopes. One of the problems with radio astronomy is that radio waves are much longer wavelength than visual light, and as we saw when we talked about light, the longer the wavelength, the lower the frequency and the lower the energy. So you need much bigger telescopes to collect the same amount of energy. Double the size of the telescope, double the diameter is 4 times the area, and so that means you need something double the size to get 4 times weaker. Well, radio waves are millions of times weaker than visual light, and so you need things that are millions of times bigger. That makes these enormous instruments. The other thing is, the bigger the instrument, the more precise the pointing. And this has to do with that diffraction we talked about. So what happened was the British government funded this giant radio telescope at a place called Jodrell Bank. And so the radio waves would come in and they'd focus up to a spot there. And you can see this thing is enormous, in size. These are like one-story buildings down in here. And so it gives you an idea as to how big this device was. Now, the United States didn't really have anything comparable to that. Everything in the U.S. was individually funded by a particular institution. No one college or university could afford anything like this. So what happened was the United States decided to establish, through the National Science Foundation, several government-funded radio observatories that scientists could go to. So one of the ones we built was at a place called Green Bank in West Virginia. And so it's in a hollow valley, so iron ore bearing mountains surrounding it, blocking radio signals. It's a no-fly zone, so aircraft can't fly over broadcasting radio signals. And for that matter, you don't even get cell phone signals or TV signals in the valley. So there's no radio signals. In fact, at the observatory, your car has to stay at the front gate. The only thing you can get near the telescopes would be something that does not give off any radio. Spark plugs give off radio, so you can't use a car with spark plugs. Diesels don't use spark plugs, so they can get close to the radio telescopes, or bicycles. I've been here, and at the dorm that we stayed at, you could either check out a diesel vehicle to drive down, or you could rent a bicycle to go down to the telescopes. The telescope you see on the left here is 140 feet across. So this ledge right there is 7 stories up. So it gives you an idea as to how big that thing is. They also built one that was 300 feet across. 300 foot across was actually, 300-foot telescope was designed to be a temporary telescope while they were building the 140 foot. And was not very well constructed, but it turned out to be so big, it was the biggest movable radio telescope on Earth, and was able to see things that other radio telescopes couldn't see, so they kept it operating, and they said, well, we'll just keep going until something breaks. Finally, though, in the 1990s, something broke. The problem was it was a very important part, and so the entire structure collapsed. They had the money that year, the government did, to fund a replacement telescope, which is actually slightly bigger, and they call it the Green Bank Telescope, GBT. Now, it's technically the Green Bank Telescope, but in the nature of how astronomers talk about stuff, GBT, they just joke as meaning the great big thing. And so in size, the dish is the size of a football field with an end zone. So it's over 100 yards across. It's 100 meters across. So it's a little bit more than 100 yards, and focuses all the radio signals up off axis to a detector that's right there. And again, you can see cars and trucks down here, which gives you an idea how big this thing is. One of the biggest radio telescopes, which was actually built prior to that, was in Arecibo in Puerto Rico. And now this was actually a sinkhole right here that they put a reflecting dish in, and so the signals come in, they bounce up here. Now the problem is it only looks at one spot above, because the dish is not movable. To get around that, the detector up here is able to move. So you move the detector over here, then radio signals from that part of the sky will bounce up to it. If you move, on the other hand, the detector, if you move the detector to the other side of this little support, then radio signals from a different part of the sky bounce up there. And so even though the dish doesn't move, you can move the detector a little bit in order to get the signals that, from different directions. And so that's how this particular radio telescope operates. It was the largest on Earth for a very long time. The reflector up here and the detector is actually located about 400 feet above. And so you can imagine workers having to go out, imagine workers having to go out this gangway which sways in the breeze and suspend themselves under there 400 feet above the dish. The dish is actually suspended slightly above the floor of the sinkhole here, and there's actually kind of like a wildlife refuge underneath. All kind of native plants and animals live under there. And so now the problem is it's in Puerto Rico, which means it is susceptible to hurricane damage, has been damaged before, and at one point they were actually talking about decommissioning it a few years ago after a hurricane hit. It's actually operated by University of Chicago. It was not originally designed as a radio telescope. The idea was it has a powerful radio transmitter that also bounces off the dish and goes up into the ionosphere, high in the upper atmosphere, to study that. They realized if you turn off that transmitter, that they can actually pick up sensitive radio signals. In fact, it was the most sensitive radio transmitter, radio receiver rather, on Earth. And so this was a spectacular instrument right here. 305 meters across, so that's big enough to put all of Jerry Jones World in here. So with parking lots. Okay, so this thing is enormous, over 1,000 feet across. Now, like I said, they were talking about decommissioning it. What kind of saved it was China built one bigger. Okay, so China built one that became operational in 2016. It's the 500-meter aperture spherical telescope, or FAST for short, because it's 500 meters across, as opposed to the 100 meters across that is the 300 meters across that is the Arecibo instrument right here. So this kind of gives you a comparison of the two. So this is now the world's largest radio telescope. So the largest movable radio telescope is currently the Green Bank telescope, or the Great Big Thing, in Green Bank, West Virginia. And the largest single dish radio telescope is this one that's in China. It displaces Arecibo as the largest single radio telescope. Not all radio telescopes look like big dishes. You could just have something that looks like a Yagi antenna, which looks like a TV antenna that is just pointed up into the sky. And I've seen radio telescopes that are that kind of design. And then this is an array of antennas that are picking up signals from space. So technically, that's a radio telescope also. So some radio telescopes don't look just like what you think of as radio telescopes. Now, the advantage of an array of multiple dishes put together is that it gives you another technology that we call an interferometry. Okay. And that involves the physics of waves. So that'll be our next topic, is how you can put signals from different telescopes together to improve the signal of your radio observatory.